Hello and welcome to Relatable Code. In this video, we're going to talk about threads and coroutines in Kotlin. So let's get started. Before we talk about threads and coroutines in Kotlin, let's first talk about the problem that they try to solve. So in this setup, we have a simple activity with a button in the middle of that activity. And with respect to our Kotlin-related main activity, we have a simple onClick listener with a log statement for our button, and we have a function called simulate process. In this function, we're trying to simulate a heavy task that our application is trying to do by executing this block of code 1 million times. Okay, this will attempt to simulate a network call, for example, or a database operation, anything that can be deemed heavy for the app's UI. Okay, so go ahead, check your emulator and run your application. Let me show you what happens when we try to run that application in that setup. So there, as you can see, your app will freeze temporarily. Okay, because it's trying to do a lot of work on its main thread, which is of course not optimal. When you want to try to develop an Android application, it has to be as efficient as possible. You can't have an application like that for your end users, where they have to wait a lot of time before they can actually interact with your application, which is why this is not optimal. Okay, and to solve problems like that, traditionally, we used to rely on threads for that purpose. Okay, so let's try to wrap this code inside a thread before I tell you what a thread actually is. Let's do this. And let's run our application again. Check your emulator. And now, as you can see, the app will instantly load the UI, and you won't see that delay which we had before we introduced this thread. Okay? Imagine you're in a kitchen preparing a meal. You're the chef, and each task, like chopping vegetables, boiling water, and frying eggs, is part of preparing the meal. In a single-threaded environment, you would have to do each task one after another. If you chop vegetables, you can't boil water or fry eggs at the same time. And this is how programs run without threading, sequentially, doing one task at a time. Now imagine you have helpers in the kitchen, each helper capable of performing a task independently. One helper chops vegetables while the other boils water, and you as a chef are frying eggs. Each helper, including you, is like a thread in a program. With multiple threads, you can perform many tasks at once, speeding up meal preparation. In computer programs, threads allow the computer to execute different parts of a program concurrently, making better use of the processor and completing tasks faster, which makes applications more responsive. Now, threads do come with several setbacks. Back in the kitchen, suppose you and your helper are both trying to add ingredients to a recipe at the same time. If you're not careful, you might both try to add salt simultaneously, resulting in too much salt. This confusion is similar to a race condition in programming. Race conditions occur when two or more threads try to access shared data and try to change it at the same time. The outcome depends on the sequence or timing of the thread's execution. Like adding too much salt, race conditions can lead to unpredictable results and bugs that are hard to trace in software because they don't happen every time. Another setback associated with threads is a deadlock. Imagine a scenario in the kitchen where you need a bowl that your helper is using, and your helper needs a spoon that you're using. If neither of you is willing to give up what you're using until you get what you need, you both end up waiting indefinitely. Okay, and this situation is a deadlock in programming. Deadlocks occur when two or more threads are waiting on each other to release resources that they need, leading to a standstill where none of the threads can proceed, which will halt your program's progress. Okay. One more thing that you have to worry about with threads is a concept called thread synchronization. And it's like coordinating activities in the kitchen to ensure that the meal preparation goes smoothly. It involves managing when and how threads access shared resources, like utensils or ingredients, to prevent race conditions and deadlocks as well. Synchronization can be complex because you have to carefully design your program to ensure that only one thread can access critical sections of a code at a time, especially when modifying shared data, like ensuring only one person can use the salt shaker at a time. Okay, and you also need to ensure that threads do release resources that they no longer need, so that other threads can use them, like putting the bowl back once you're done mixing ingredients, for example. Okay, and you also have to keep in mind that you have to avoid situations where threads wait on each other indefinitely, which will lead to deadlocks. Okay, synchronization tools and techniques like locks and semaphores and monitors are like kitchen rules or protocols. They ensure that everyone works together in harmony without stepping on each other's toes or causing chaos in the kitchen. Now imagine you're running a restaurant instead of just a kitchen, with many tasks that need to be done quickly and efficiently, like taking orders, cooking meals, serving customers, and cleaning up, for example. In this environment, you need a way to manage all of those tasks smoothly without causing any chaos or delays. Okay, and this is where coroutines come into the picture in the world of programming, especially when dealing with concurrency. Coroutines are like having a team of highly efficient and cooperative waiters at your restaurant. They can start serving a table and then pause to take a new order when a new customer arrives, and then resume serving the first table once the order is taken. Unlike traditional waiters, in our case, threads who can only focus on one table at a time until the meal is served, coroutines can juggle multiple tables, starting, pausing, and resuming tasks as needed without getting overwhelmed. Okay, and in programming, coroutines are a powerful feature of Kotlin that allows developers to write asynchronous code in a more linear and readable way. They let you perform long-running tasks such as network calls or database operations without freezing the user interface of an application. Coroutines bring order to the chaos of managing concurrent tasks, like having a well-organized system for your waiters to know which tables they are serving and when to pause or resume tasks. Structured concurrency ensures that your code dealing with asynchronous operations is clean, manageable, and less error-prone as well. Now imagine if each task at the restaurant required a new waiter. No matter how small, you would quickly run out of space and resources as well. Threats can be like waiters. They are expensive to manage in large numbers. Coroutines, however, are lightweight. They allow you to handle many tasks with fewer resources, similar to training your waiters to handle multiple tables, for example, and they will do that efficiently without needing to hire more staff. Coroutines have the special ability to pause and resume tasks without blocking. This is like a waiter who can take an order and then pause to greet new customers and then return to complete that order without any table feeling neglected. And this capability ensures that your application remains responsive, which will improve user experience significantly. In a busy restaurant, mishaps can happen. A spilled drink or a dropped plate, for example. How you handle these incidents can make a big difference. Coroutines provide mechanisms to gracefully handle errors that occur during asynchronous operations, which ensures that one mistake doesn't cause the entire system to crash. And this built-in error management makes coroutines a safer choice for handling concurrency inside your application. Now, outside of the kitchen, creating a coroutine in Kotlin is very simple. So instead of writing a thread like that, you can write coroutine scope, and you can pass a context like dispatchers.io, and to launch this coroutine, you can write .launch. Okay, we will cover this syntax in detail in future videos, but I want you to get an idea of how to create a coroutine. Okay, now let's run our application again. That's our application. And as you can see, we can directly interact with our button now. We don't have to wait for this process to finish, basically, because this process is now being executed by a coroutine. Okay? If you like my content and you find it to be relatable, please don't forget to leave a like and subscribe for future content, and I'll see you in the next video.